Okay, so for today's Campus Rec Leadership Summit webinar, my name is Steve Hayes from Acer Sports Flooring, and we're going to talk about when disaster strikes a gymnasium, specifically regarding wood floors, how to process a water event on a maple gym floor, and we'll follow up with a little bit of the history of wood gym floors. Um, Going back from the 1920s kind of up to the 2020s as we sit here today. So looking forward to a little time with everyone today, and hopefully this will be some good information for you to take from this presentation. So we'll get started here. Moisture, as everyone knows, can wreak havoc on athletic floors, and certainly it can ruin your day when you walk in and you've got the broken pipe, or you've got the sprinkler head that's been knocked off by a volleyball, or in certain cases you had the tropical storm, roll in and dump 5 or 6 inches of rain on campus, and all of a sudden something's flooded. And while the floors may look like they're beyond hope, most of the time, 80% of the time, by our estimations, we can assist with salvaging the floor, repairing the floor, drying the floor out, and collaborating with the restoration industry to find solutions. And, the restoration industry is extremely important in the process because in most cases, your campus maintenance, buildings and grounds individuals will be bringing some type of a restoration company in the event that you have a water damage to your facility. So we have found that it's much more effective for everyone that's involved, to work collaboratively than to be working against each other. And the one thing that we believe we bring to the table in this situation is that we look at it from a big picture perspective. We don't just look at the floor, and we try to factor in, the roof, the walls, the bleachers, everything else that is impacted in those gymnasium spaces, and make sure that we're talking about it from a total perspective and not just the floor perspective. But that's kind of a misconception in the industry out there, that once a floor gets wet, there's no turning back. It can't be fixed. And while many times it looks really bad, we have been able to dry out a lot of floors and save a lot of floors. And I think at the end of the day, that's good for all of us. So what should be your first steps when the water event occurs? Again, you come in with your coffee on Monday morning, and you've had a roof vent blow off, and you've had water, dropped on the floor, and what do you do next? I mean, obviously, I'm sure you all have protocols on campus, who you would reach out to. They already may be involved, but we certainly want to identify the type of water that entered the space. That's important, whether it was the creek that runs along the side of the building, or it was a sanitary sewer of some type in the worst case scenario, or it was just plain old sprinkler water or rainwater that came into the space. That's going to be important as you go through the process. Determine what type of floor you're working with. That's generally done by cutting a hole, a small hole, and we'll show you some pictures here coming up. But it's generally done by cutting a small hole in the floor and taking a look and seeing what you have underneath it. And what you have underneath it can vary widely. I've got several photos here that will show you the different looks that you can find when you get, and you cut into that floor, because ultimately, if we repair the floor, we're going to need to know what's under the floor. And then the next bullet point, are there any hazardous materials present? That little window pane that we're going to cut into the floor is going to give us a pretty good idea of what the products are that comprise that subfloor. And based on our experiences, we can tell that some products are most likely going to maybe have some hazardous materials in them, and some products are much less likely, in addition to us knowing then what we're going to need to do to repair this floor and the scope of what's going to be involved to repair the floor. Do your best to assess how much of the floor has been affected. That's a tough one, to be honest with you, because you may have a roof vent that's been blown off of your building, and you may have a concentrated wet spot of, let's say, 6 foot in diameter, and it's in a 20,000 square foot space. You might think that it's, well, you know, it's located in this 6 foot diameter area. The reality is that if that water gets below the wood floor, it then begins to follow the contour, if you will, of the concrete subfloor. And depending on how old your building is, depending on how good the concrete slab is from a planarity standpoint, that water can be kind of migrating all over the place. And one of the ways that we can attempt to determine where the water has gone is by actually taking moisture readings of the wood in the entire gym, and then we chart that out, and we would set up basically a grid, and we would try to determine how much of the floor has been impacted. So do your best to assess how much of the floor has been affected, but again, that's a tough one, and that may require some assistance from outside folks, such as the restoration company or you know, us coming in there and taking a look at it. Did the water infiltrate below the 6 mil poly under the floor? So as most of you know, and I'll show you a picture of this here coming up, as most of you know, you have, in most cases, a 6 mil poly of visqueen, if you will, that gets put down on top of the concrete, and then the subfloor gets laid and the wood floor gets finished. That's the general construction process, and you'll see that in pictures. Did the water get in between the visqueen and the concrete is what we're looking for here. We can dry floors out to a great extent. We really cannot effectively dry the space between the concrete and the visqueen. So if that water gets infiltrated in between the concrete and the visqueen, it's really, really hard to dry out. We need that water sitting on top of the visqueen in most cases for us to have a real successful shot at drying that floor out. So so those are just some steps that you want to think about when you have this event occur. And so let me show you a picture here. This would be a perfect example of when we talk about what kind of water has infiltrated. Clearly this was, you know, dirty, muddy water. For many of you who haven't seen a floor that gets flooded, and we talk about how these floors kind of blow off of the concrete, you know, this is what we're talking about. I mean, you've got a good 2 to 3 foot, you know, humping of that floor. And, you know, this would obviously be a situation where be pretty hard to salvage this floor, you know, after the fact. So what we would want to do here is kind of evaluate what the floor is, what the slab depression is, and then start kind of evaluating what options there might be to go back with a replacement floor. But just an example of exactly how bad it can look, for lack of a better term, when you have a water event. Clearly, this was something where it was probably the creek scenario next to the building, and it overflowed and just completely infiltrated the gym space. So here's another example, and you can kind of see what I was talking about earlier, where you have the visqueen and then you have the subfloor on top of it, and this is a plywood subfloor. So you can see that it has obviously really kind of swelled and peaked. You know, depending on you know, the extent of how much of the gym was infiltrated. Obviously, there's been a fair amount removed right now. You know, this is just another example of what you might see when you have a water event. This was an example, actually, I worked on this project. This was an example during the polar vortex of 2019 in the Midwest. This was an older gymnasium that a pipe burst and dropped a lot of water on the floor. And the one reason that I like to use this picture is because it shows a really, really old floor design where you have all those individual boards that are present basically in that floor. These types of floors, in many situations, they do have some hazardous material beneath them. So when you see these short boards, if you have a gym like that, it's really hard for them to actually swell and lift up like they have because of the way that they're constructed. They're constructed with steel channels underneath, and the material is is essentially attached to those steel channels. So very hard floor, very old technology when you see those individual boards. Very difficult to go in and repair a section of a floor that looks like that. And in all these photos, you're also going to see bleachers. You're going to see other parts of the facility that are impacted. Specifically bleachers. That are going to have to factor into how your repair and or replacement is organized and is structured. So that's a good picture, like I said, because of the actual type of the system that is present there, and the fact that you have a very low profile on this system. So you may only have 1.5 inches of slab depression to work with, and that can present challenges when you look at how are we going to repair and or replace. Repairing a tough floor like this is pretty tough. As you'll see, or as we'll talk about, they just don't make a lot of this type of material anymore. So you want to get someone in. This is a good picture. You want to get someone in to start kind of doing an assessment of what's going on. In some cases, like right here, you'll see they've cut back from the wall, probably to relieve some pressure, because I don't know if everyone understands this, but just real quickly, when maple expands, like in a minor water event, even in a high humidity event, let's say your air conditioning system shuts down and it's a real hot, humid day or weekend, and your wood is going to expand across the face width of the material more than it will expand across the length of the material. So most boards are 2¼ inches face width, and as you'll see there, they have cut back from the wall probably about 18 inches. And then as you'll see to the right there of the gentleman inspecting that floor, you will see that they've already brought in some blower systems that they are looking to try to extract the water out from underneath the floor. So, this would be a very typical example of kind of smaller, more manageable water event where, we want to open the floor up, we want to get some air moving, and we want to get that moisture out from sitting on top of the visqueen. And so that's kind of what you're seeing right there. The next picture is actually that little cutout that we talked about when you're trying to determine what you have that you're dealing with. And there again are our short little boards that we talked about 2 pictures ago. And as you can see, there's kind of a black mastic, so to speak, that's underneath that floor. And when we talk about making sure that you understand what is underneath the wood, that would be this situation where you want to know, you probably want to have it tested with your environmental people. And maybe most of you have already kind of removed these materials from campus, but these gym floors are old. You know, we're going to talk about the history of gym floors, and really they kind of go back into the 20s and the 30s. And you know, this type of system that we're looking at right here, that's going to be circa 1950s, 1960s, and we still see a lot of them, quite frankly. So they do still exist, and and in most cases, you're going to have some type of an environmental assessment of what you've got going on there. So just wanted to show that. The next picture is an interesting picture because it shows the visqueen that was put down, and it shows the removal of the subfloor. As you can see, the floor is still under the bleachers off in the distance there. So they cut in front of the bleachers, they removed a section of flooring, but interestingly enough, all of those little red spaces are where pads used to be under 2 layers of plywood. And what happened was during the process, and this can happen during the process of trying to dry the floor, the pads get compromised and then they basically break down. And a lot of that gets into the specifics of what the pads are made out of and what the process is. When you're talking about you know, someone coming in and drying the floor, how they're going about drying it, the process that they're using. And again, in all fairness to everyone involved, whether it's restoration professionals, insurance professionals, anybody, you know, these gym floors aren't something that everyone sees every day. And so we believe that that's where, you know, we can bring a certain eye, you know, and a certain knowledge to the conversation so that, you know, we can talk about situations like this where if you overcook the floor, so to speak, or over dry it, you know, you have to be careful so that you don't have this pad degradation, you know, throughout the space. So that's why I like to show that picture and talk about that a little bit as well. This next photo is just an example of where it might be hard for you to tell, but this is an example where the visqueen has water underneath it. And you can kind of see because the visqueen is almost stuck to the concrete. And unfortunately, as we talked about earlier, you know, that's a bad situation because it's difficult, if not impossible, to try to dry that space that exists in between the top of the concrete and the visqueen. So, you know, hopefully when your floor is installed, you know, there's care that's being taken to do the best that the installer can to seal the seams of the visqueen so that if you do get this water event, you know, you can keep most of the water on top of the visqueen, and then you have a much better chance at having some type of a remediation, you know, a repair instead of a complete replacement. So that was a picture we had where there's the water's under the visqueen. Here's just a nice picture that I like to use of a floor that to the untrained eye probably doesn't look like there's a problem with it. We see this a lot. We'll come into a gym and maybe someone's not really sure if they've got a water problem. Maybe it's by a water fountain. Side note, water fountains in gymnasiums are major culprits of water damage in gymnasiums because they wind up leaking. But as you'll see here, this is just a little, probably 3-foot level, and we've even got 6 and 8-foot levels that we'll come out with, and we'll shoot a floor. And as you can see there, you've got a pretty substantial, you know, hump in that floor. This could be a situation where humidity is involved. Maybe the HVAC system wasn't operating correctly, and it's not like monumental water damage like you saw in that first slide with the river water coming in, but it's certainly a problem. And like I said, this is one that we see a lot where, you know, a lot of times folks aren't even sure that they have a problem until maybe they step on that spot and they realize that there's a lot more flexibility in it. So moving forward here, When I talked earlier about, what's under a gym floor, and I talked about how you always want to know what you're dealing with. You never want to blindly go into tearing a floor out until you know what is underneath it. So you can plan accordingly and be as educated as you possibly can as you go into the process. So I mean, here's a perfect example of, here's a floor that was built basically like a traditional house construction would be built, with large floor joists. There may even be some sort of a mechanical run or a mechanical chase that goes under that gym floor. We've seen that in the past. We've seen construction like this in certain territories, certain geographies of the United States, and obviously this is a whole different ball game in terms of what you're coming back with. And just an example of why it's important to see what's underneath as you get into the process of what you're going to do coming back with repair/replacement. This just gives you an idea when a repair is done, and in most cases you want to lace the material back in. So, lace it in or finger it in, basically, where you're going to stagger the end joints. You don't want to come in and just cut a straight line and put the floor in, because you're really kind of sacrificing the integrity of the maple. And you want to take your time. You want to come back and do the repair the right way. And this is something that you should be aware of, using random length maple, that you want to come in and it is more time consuming for sure. So it is going to cost a little bit more, but it's going to be a much better repair from a structural perspective, and a much better repair from an aesthetic perspective as well. If you do it this way, and then maybe you sand the whole floor, and give it new paint, new seal, new finish, you might not even know that repair ever took place. So just wanted to kind of throw that in there. These next pictures are from a project that was done where they had an existing synthetic surface and wanted to do a modernization to the facility. And so they came in and they ran some new electric lines. You can see off in the distance, there's some plywood there. I'll give you a close-up of that. There's some plywood there where they ran some new electric lines and some new technology networking lines for scoreboards and such. And then they filled that space, and then there was a wood floor that was built on top of the existing synthetic floor. And literally within a year of completing that brand new wood floor on the competition area, there was a construction project going on, like for a fitness center, and there was a storm, and a temporary door got knocked loose, and the floor flooded significantly. So, one of the reasons why I put this out there is because, we always want to be aware of, if we're having any sort of growth or anything of that nature. And in this case, when we did tear the floor off, we did find that there were some issues with that existing plywood, again, that was only about a year old. So this started out where the original thought was that there was only a small area that was affected by the water infiltration. And I'm going to go back to the first, and as you can see, it was very wet when we got all of the material. So I talked about this earlier. You have to be careful where you think that the water is limited to a small area, because it can be very deceptive, and it's hard for anyone to know where it may or may not have migrated to. But you always have to be aware of the fact that it can migrate once it gets under the floor, and it will do strange things. And in many cases, it's not as bad as it seems, and in other cases, it's worse than it seems, just depending on the details of the situation. So that kind of brings me through the Watr event in a facility, and hopefully that's been some good information. And then I wanted to talk a little bit about the history of wood floor designs, because I think it's important. You've seen in these photos that I've presented about water damage, and water damage obviously occurs on old floors as well as new floors. But a lot of the pictures that you've seen would be what we would consider older floor designs. Not all of them, but a lot of them that you just saw, as we talked about with the short little 12-inch boards. That's an older wood floor design. And so I want to talk a little bit here to kind of wrap things up today about the history of wood floor designs. And really, that process goes back quite a ways. I know from my years in the campus recreation marketplace, there's a lot of John Wooden fans out there that are directors and associate directors and employees at Campus Rec. And John Wooden's one of my favorites, so I put this little graphic together to kind of illustrate the fact that technology has evolved over the last 100 years, 90 years, of our place here. And obviously that's an old, and I can't say that's an actual shoe that John Wooden wore, but it's an older gym shoe. So keep that in mind as we move forward here. I tried to pull this up. It's very hard to see, I understand, but basically the bottom line is that this is an illustration from a patent from 1926 for a way to construct a wood floor. Now, I won't say that this was designed as a way to construct a wood gym floor, because it really wasn't. The early evolution of wood gym floors was that they were designed to be used in factories because of their durability primarily, and the ability to roll heavy carts with textiles, among other things, across them and not damage them. And that's where northern hard maple really came to be, because of its density, its slow growth, and its hardness. So you can see there, it's just a simple, let's call it a 4x4, and it's got the brackets that hold it in place, and then the wood is nailed, the maple is nailed to that sleeper essentially. And it would look kind of in current day, it would look like this system right here, which is an older system, but certainly something that is still used occasionally. And you certainly may see that if you open up a floor that maybe was built in the 70s or 80s. This was kind of the first generation of trying to create some shock absorption and resiliency in a wood floor. And again, if we go back and look at this 1926 illustration, there's no shock absorption, there's no resiliency. It was designed for durability and longevity, quite frankly. So then the next slide that I have is another example of an illustration from a patent application in 1938, where it was a different design of a floor system, where there was a steel channel that was introduced, and then steel clips were inserted into the steel channel and held the maple in place. So you didn't nail the maple in, you inserted a steel clip, and that clip wrapped around the tongue of the material and held it in place. This would be a picture of what a gym floor would look like with that type of a design. So we have some patents that were issued in the 20s and the 30s, and they made their way through the factory floor process, as we call it, where they were used in factories. And then someone decided that it probably would be a good idea to implement some of the same technology at that time into gym floors. So you can see you've got a steel channel, you've got the clip basically holding the piece of wood in place, and you've got some, in this picture, closed cell foam that is really kind of more just creating a sound deadening than it's creating any type of resiliency or shock absorption. So this floor would be something that we still see out there. It's a extremely durable floor. You're going to see this in many high school applications, 50, 60 years old. And I will tell you that from the end user's perspective, it's a hard floor to play on. So your knees, your ankles, your back, you know, you're going to feel that. It's pretty much like playing on concrete. It's a hard floor. And so moving forward, this is just one more drawing. I don't actually have a date for this one, but it just gives you a little bit of an idea of even how they started to layer 2x3s and 1x6s into kind of a basket weave fashion, where they were creating the subfloor to have airflow and to have a little bit of resiliency to it. And you know, this is just giving you an idea of when you open up a floor, something that you might see. It's an older drawing and an older design, but you know, certainly one that was widely used years ago. So what does that bring us to? It brings us to a concept that we feel real good about, that I'd like to throw out there and just talk a little bit about. We've designed what we call a replay series, and the term replay kind of means what it says. It's taken an old factory floor and it's repurposing it into a modern floor that provides performance values much better than the original factory floor. And the whole concept here is, with the first two designs, that you're not having to tear out all of the existing floor, that you're only having to tear part of it out, and then we're going to retrofit it. And when we retrofit it, it's going to have performance characteristics that will actually, in some cases, it'll meet pure, which is the guidelines that the Maple Floor Manufacturers Association look to for performance and uniformity rating. So this is we believe this is somewhat cutting edge here, where we're taking and we're designing floors that are specifically going in to repair and replace a floor. Replay 2 is a system that is designed, and you can see those steel channels right there. It's a system that's designed to go over a floor such as the one, I'm going to scroll back here real quick, such as this floor. So you have that steel channel there. We can go in and tear out all the maple, basically, and then we can come back with a floor that has resilient material, it has a subfloor structure, and then it basically rests above the existing steel channels. And so it provides great shock absorption, great resiliency, and it also has a self-blocking mechanism so that if the floor is stressed with, say, a portable basketball goal or a scissor lift to change lights, if the floor is stressed, it will bottom out and it will protect itself from damage in most cases. Okay, so the third system is called Replay 3, and as we try to illustrate here, it's designed as a self-leveling subfloor system for concrete substrates that are not suitable, do not have the planarity of 1/8 of an inch in 10 for us to install a new floor. And so this would be an option if you were to remove all of the existing floor, and then you had a significant planarity issue, which is hard. It's hard to know. It's impossible to know until you tear off the existing floor. And then you have a planarity issue. You have two options. You can pour a cap on it and self-level it, or you might want to go to this option, if time is of the essence and you're under a really tight schedule to get the project done. This is an option as well as replay 3. So I'm going to go to the next example, which actually does have the correct picture on replay 1. Replay 1 is designed to go into a space that has a fixed sleeper, and a sleeper would be like we've talked about, that 2x3. It might be a 2x4 depending on the age of the facility, and in most cases it has steel clips that hold the 2x3 or the 2x4 in place, and those steel clips sometimes in between have a grout or cementatious material or even a mastic adhesive as well that basically kind of set the 2x3s in place. And so when you tear those floors apart, it can be a complicated process. And replay 1 was designed, you can see there the reference to number 5, where it talks about having a resilient pad supported by a replay 1 steel channel. That's right over here. I don't know if you can see my cursor, but it's right over there. So we basically built a hat channel, if you will, that sits on the top of the existing sleeper, and then we come back with a floor system that has resiliency, shock absorption, it meets pure, and it also allows you to do the project without having to tear the entire floor out of the facility. And subsequently, you have that variable then of what does your concrete subfloor look like once you tear everything out. And this is a design that we're excited about, and it's brand new, and we're looking forward to getting this into spaces as construction schedules get compressed, and as we want to eliminate the variables, for cost overruns when we tear out the whole floor and we find out that the slab is not really meeting the standards for the new floor to go in. So that's the replay series in a nutshell. And to go back to my shoe analogy, so we had John Wooden shoes, and I showed you some of the older floor systems, and then I showed you ways that we are looking to modernize old floors, give them a facelift with the replay series. And real quickly here to wrap up, I've got just a couple of quick slides. So we've got LeBron shoes, which obviously are a bit more technologically advanced than John Wooden shoes were back in the day. And we're excited about some new systems that we are currently putting out there. And this one's called Anchored Power Lock LP with Vert. Vert is a new resilient foam technology that is tremendous for vibration reduction. We're always trying to figure out how to reduce vibration in these floors, and it's tremendous with shock absorption and resiliency. It's antibacterial, antimicrobial. It is widely used in a lot of athletic applications that are not floor related, as a source of resiliency, shock absorption, in some cases body protection for athletes. So widely used, and we're excited to incorporate it into these systems. As you can see, there's a notch in that sleeper. So we're basically taking two different types of subfloor technology with a plywood sleeper. We're notching it out, and then we're using 1x6s as the second layer of material. We're anchoring this floor to the concrete substrate. And again, what it's allowing us to do is it's allowing us to give a floor that provides shock absorption and resiliency. It meets pure, but it also will bottom out when that little housing, that little cutout is maxed and the floor is flexed. It will protect itself from being over flexed by a portable or a scissor lift or loaded bleachers or any of those types of products. So that's one of our new systems that we're excited about. And then the second one is we put the advanced Vert material into an older system, which is just a simple scissor lock where you have 2 layers of 1x6s. We've got a little twist on that where we've got 1 layer of 1x6 here. So one of those is 3/4, one of them is actually 1/2 inch. And then we're using 1/4 inch vert hexagon shaped pads for the resiliency. And again, to get 1/4 inch material to perform the way that this material does is really cutting edge in the industry. And so here's another floor system that's going to meet pure. It's going to give you a nice low profile solution if you're going back in, and replacing an old floor that had a low profile. This is a great solution that we're really excited about. Just kind of for the record, for these drawings, I do show the vert material in blue and green, but when we actually install them, the material's in black because, well, it's going to be covered up for all of eternity, hopefully, and we don't see the need to color the material when it's going to be covered up and no one's ever going to see it. But we're really excited about the vert product, and certainly we still have all of our existing systems as well. So looking forward to getting this introduced and talking to folks about it. And I think that's going to end my time with you today. I hope that this was informative, and I hope that everybody learned a little bit here today. And certainly I'm always available. I know many of you from my years kind of going to NERSA and Campus Rec, and all of the events that the campus folks are attending. So looking forward to talking with you. Hopefully it'll be soon, and I hope you all have a great day. Thanks a lot.